Hello? Hello?
Sir, yes, sir. Due to the large audience, we mute the audience. You are
Okay,
audible,
okay,
sir.
okay. Okay, I'm audible. Okay. So what I will do, in most of the cases, you people may have seen a robotic systems. Okay, and a lot of videos, YouTube videos are available where you can find this kind of robots. Okay, but what I will show right now is a toy robot. Okay, and this toy robot is like this. I think you can see this one, this robotic systems, and this is the toy robot. Okay, looks like a toy, and this is not a real one. Okay, but if you see this robot from the front, okay, it looks like a exactly it looks like a robot. That means it does not look like an artificial kind of things. Okay, or it is a kind of play type of robotic systems, or it is a toy type of systems. Now you can see that this toy robot, generally we use this toy robot for teaching the subject robotics subjects. Okay, and in most of the cases, what we do generally when we go to the class for teaching this subject, robotic subjects, we generally take these robots because we cannot take the industrial robots models to the classroom. It's not feasible. It's not possible at all. Okay, so you can see that teaching becomes very funny, and the students also at the same time they also learn a lot of things. Okay, just by seeing the systems. Sometimes we believe that seeing is believing. Okay, so whenever we find this kind of things, okay, and in front of our table, whenever we are teaching to the students, and the students can have a feel about this particular robotic systems, whatever the questions they have in their mind, mostly they get answer from this toys. Okay, so we can say that the toys, generally we use these toys for engineering. Even we are using these toys for the engineering education purposes. Now, those who know about these toys, then you probably know that this toy, this robotic toy, it can move from one location to another location. So now the question will arise, the question will come that how it will move from one location to the another location. So how it is possible to move it. Now you can see that it has some arms. Okay, so I'm just rotating the arms and moving the arms. These arms are moved. Okay, I'm moving it. I'm moving it. Now you can see that whenever I'm moving the base part, it rotates almost by 360-degree rotation is possible. Okay, and when I move this arm part, okay, so this is moving like this. This is moving like this. When I move this arm part like this, now the question is how this will be moved. Here in the case, if it is a manual type of systems, manually you can see that manually there is a joint. Here there is a joint. We call this as a revolute joint. Those who are mechanical background, they can understand what's meant by the revolute joint. So if there is a revolute joint, with respect to this revolute joint, this arm can move if this is a base part, if this is a fixed part, then with respect to this fixed part, this is moving part, and it moves with respect to this joint. So this is possible. Then you can see at the back side there is a black portion is provided over here. Okay, and this black is nothing but this is called as a this part, this black part, this part is known as a motor part. Okay, so this is the motor, artificial motor. And this is a plain motors, and this is a toy motor, and this is not the real motor. But you can see that look-wise, it looks like it looks like a motor. So, and then you can see again there is another motor placed over here, and this motor is again a revolute motor, revolute joint over placed over here, and then this arm can also move. This arm can also move. It's possible to move it. Okay, and already I mentioned that there is a base. There is a base. So with respect to this base, this arm, this totally it can move by 360-degree movement is possible. Like this way, this movement is possible. This is possible. Okay. So at the base also there is a motor, but this motor is a hidden motor because this motor is placed inside this black base portion inside it. So that's why from the outside you will not be able to see this motor, but actually there is a motor plus. And this part is known as a gripper. Technically, we call these as a gripper portions for robotic systems. Okay, and this gripper can have a rotations like this. It can rotate like this, or some. It can also rotate like this. It can also rotate, have a rotations like this. It can also rotate like this. The black portions can also rotate like this. So we generally call a robotic system has a 6 degrees of freedom. Okay, so 3 degrees of freedom we generally called in the link of the manipulator range, and the 3 is at the gripper end. Okay, so here there is a 3 revolute joints are placed. So one is rotation about x-axis, another is rotation about y-axis, the third one is rotation about the z-axis, and these are known as the pitch, roll, and the yaw motions. And these are, technically speaking, this portion is used for the, we can say that, for the orientation purposes. Okay, and this link, and this link along with the base rotation, this is used for position purposes. So both the position and the orientations of this device can be changed by rotating the different joints. So whenever we introduce these subjects of robotic subjects to the students, and then the students automatically they have a lot of queries in their mind that what is known as a orientation, what is known as a positions, how many degrees of freedom is required, what is joint, okay, what is the actuator means, what is link. So everything can be described with this talk. And I will show you the real hardware setup of these systems, which is known as an industrial robotic systems. And if you see the industrial robot, the look-wise, the industrial robot will have the same look of these artificial toys. So only you can see that on this is a small one, okay, very small one, and the industrial model we have a big model, and that big model generally, what I say that this is, we can say that it is 100 times reduced its original shape or original size. So conceptually you can see through the toys we can explain to the students a very difficult engineering concepts that is possible to explain to it. And so that's why this is the beauty of the toys. And the students or the children can use this kind of toys for playing purposes, or this can also be used for educational purposes, training purposes also. Even for the training purposes also, this kind of toys are used. Okay, those who joined in an industry, say for example robotic industry, so before they are given a hands-on training on the toys, they have to go through the model. Okay, so this model or these toys, these are very important for them, and through which the initial learning of the robotic systems or automation systems can be carried out by the engineering students. Just a minute, please.
কি হচ্ছে, লাইভ হচ্ছে? So, meantime, I announce that our next session from 2:30 p.m. Sir will continue. Please wait. Please wait. তুমি একটা লাইক মেরে দিলে নাকি? তুমি একটা লাইক মেরে দিলে নাকি? দেখি কেমন লাগছে, কেমন লাগছে দেখি মোবাইলটা। মোবাইলটা দেখি। কাজ করছি না,
মাঝে মাঝে চলে যাচ্ছে।
তার মানে ওখানে হচ্ছে বলে।
হ্যাঁ,
তার মানে ওদের হচ্ছে, আমরা দেখতে পাচ্ছি না।
কী হচ্ছে?
মানে অনুষ্ঠানটা হচ্ছে, আমরা ওটা দেখতে পাচ্ছি না। এখানে কিছু হচ্ছে।
এখানে কি ঝুম
কোথায় গো?
সবাইকে বলে
কাদের কাদের বলে?
কেউ খাবে না,
হ্যাঁ,
সবাই বাড়ি থেকে খাওয়া যাবে।
তো
অফিসার বললো ঠিক কাজ দেখতে, আমি আর কিছু বলিনি। আর বাকিরা বললো সবাই খাবার নিচ্ছে। সুব্রজিৎ স্যারও বললো আমি বাড়ি থেকে খাবার নিচ্ছি, দেখছি বলে মনে হচ্ছে খাবে না।
Okay, so we can say that means this kind of toys they have really importance in engineering education. Okay, and not only that, we can make similar kind of toys of a low cost, and this can be provided to the students maybe at the class 5, class 6 level. Okay, and so that they will have a better understandings of the use of a robots, or they can have some sort of idea about some machines or a components, or only for the entertainment purposes. Also, from the joy aspect of joy, also they can use this kind of toys also. So this is one thing, and then we have another systems. Okay, and this is known as a toy. This is another kind of toy, and this toy is basically this is known as a humanoid robotic systems robot. Okay, and hello.
yes sir, you are audible sir.
Okay, so this is an robot, and this is for the play purposes. It can be used, and it looks like a humanoid, human type, humanoid choice. So it has a hand. You can say this is one hand, this is another hand, this is the leg portions, this is the leg portions, and this is the body portions. Now this can be used for entertainment purposes, and this can be used for what I say that robotics training purposes to the engineering students. This toy can be used, and this toy means this design is also very very essential to understand the design, how the how this kind of humanoid type of toys can be designed. Okay, it has a number of parts, number of components. Okay, and these components are specially designed. A lot of thinking process is going on for making this kind of designs, and they have added with the number of motors. So at the back side, you can find that there are number of motors are there. Okay, and these are the different motors placed over here, and these motors are clubbed together with the different links, and ultimately you can make make this kind of devices. And this one is you can see that if you compare our human body with a robotic type of systems, our hand, okay, our leg portions, hand portions, the head portions, everything has a everything can be moved. Okay, and similar to that, these robotic structures of the humanoid one, each and every parts or each and every components can be moved. I cannot make it in the working conditions right now, but you can see that there are different motors. Black portions are known as a motor. So whenever these motors are coupled, motors are charged, okay, you give the power, then that particular motor starts its rotations. And if the motor starts rotations, then the electrical motion of the motor that is converted into the mechanical motion. And whenever this mechanical motion is connected with some link, then that particular link will also move. Okay, so this is a case, and you can see that this is the leg portions. Okay, and this is also the another leg portions, and everything you can see that it is basically copying the human body to some extent. It is copying the human body, and this can move. I will play some video through which you can see that this particular robotic systems, it can also work, it can also dance, or it can do certain body exercises. So let us play. Okay, I will play that video later on. Otherwise, first I think I should complete the demonstration purpose. Demonstrations. This is like a toy. This is another toy. This is an electronic toy. Okay, and this is known as a mobile platform. This is considered as a mobile platform. And most of the cases, you will find that our undergraduate students, okay, in most of the cases, whenever they have to participate in some competitions, mostly they build up the toys and mobile type of toys, moving type of toys. So this toy can also move, and it has a wheel. This is a wheel systems wheel. Okay, and the front portions is known as a caster wheel. Basically, it's a support wheel. The back portions is known as a power wheel, so it can move from one location to the other locations. And there are a lot of electronics is there, so this toy can be used at the higher level of engineering. And it is a microcontroller based systems, and you can have to write the programs. You can save the programs into these microcontroller chips, and then depending upon your program, this will
অ্যাকাউন্ট
be
সেকশনে
able to
গিয়ে
move
বলো
from
যে
one
স্যার
location to the
যে
other
আজকে
location. So
খাওয়া বলেছিল
it can move
খাওয়াগুলো
in
পাঞ্চনের
a flat surface.
আপনাদের নামগুলো লিখে
Basically,
দিন
it can move on a flat surface. So this can be powered.
অ্যাকাউন্ট সেকশন
Okay,
যাও
this can be powered.
দীনবন্ধু
This
আছে
is powered and externally powered and individually powered. Okay. So you can see at the back side there is a bottom portions. There is a motor placed over here. There is another motor placed over here. So there
এইখানে
are
এসো একবার
two
এসো
motors.
একটু
There are two separate motors placed, and whenever these two motors are actuated, then what will happen? This particular the wheel will start rotating. Okay, it will start rotating, and the
আচ্ছা
motions
আচ্ছা
will
পেয়েছি
be
দেখছি
that starts rotating, and also at the same time, this mobile robots will move from one location to the another location. Now the question is that, say for example, if you want to move this particular robot, okay, along a path which is a carved path, okay, is a planar carved path, then what you can do, you can increase the
টিকটিক
speed
ছেলে
of
যে ছেলেটা বসে
one arms, one
তার নামটা লিখতে বলো
wheels,
গো
and you can decrease
আর
the
ওই
speed of another wheel. Say for example, the speed of this one
অ্যাকাউন্ট
is
সেকশনে যে
higher than the
আছে
speed of
তাদের
this one.
নামগুলো
Then what will happen? Then some steering action will take place. Okay, so it will move at a faster speed. This will move at a slower speed. So it will get turned on the right side directions. If you want to turn in the left hand side direction, then the speed of this wheel must be higher than the speed of this wheel. So it will move in a left hand configurations. So in this way, you can make some sort of programming, and our students of electrical students, electronic students, or maybe instrumentation students, mechanical students. They can be exposed to this mobile robotics. Okay, and they can play with this kind of systems. And another thing is that if you wants to make it more intelligent, sometimes the students are interested to make the things more and more intelligent. Okay, and sensors, or maybe some strain gauge based sensors, load cell based sensors, you can attach it so that whenever it finds some sort of obstacles in front of it, then it will not hit the obstacles. Okay, it will avoid the obstacles. It will come back, it will move in the back directions, and then it will take a turn. That by this way it will avoid the obstacles. So whenever this kind of systems will have have programming. It has sensors, it has actuators, it has mechanical parts, it has controllers parts, electronics parts. Okay, so all this will make this device intelligent. This is another setup, these systems. Probably all of you have seen this kind of systems. And nowadays, people are interested to make more and more products which are basically having interface with the operator. We call these as a man-machine systems. Okay. Even the people are now developing some sort of toy type of systems which will be controlled by the human. Okay, understand that one. Say for example, if you blink your eyes, okay, so that will give an information to the toy, and the toy will also blink, or the toy will do some exercise, or it will do some activity depending upon the information that you have passed on to the systems. So there are machines or equipments or the systems of theirs which gather the information about our brain signals, okay, brain thinking. So there are toys at this which will just copy what you are thinking at a lower level, not at the higher level. So if you are thinking that you should stand up from your sitting position, you want to stand up, or if you think that you should sit from your standing postures, okay, and this must be copied by a toy. Then the question is how your information, how your brain thinking can be captured and can be transferred to the toys. So people are working, and there are some sort of low-level electronics gadgets, tools are there, which is known as this is sometimes known as an Emg Sensors. Okay, so which capture the muscles activity of the human's muscles activity, and there are certain EEG sensors appears, and the sensing tools appears, some electrodes appears, and these electrodes will capture the what I say that the very small level of signals, electrical voltage signals, and if you amplify them, okay, then you will be able to detect the thinking activity, the very simple type of thinking activities that a person is doing. And once you capture that data and then you process the signals and find out some conclusions, okay, regarding your brain activity, then that signals can be passed on to your toy, and the toy will do certain activity based on the programs already developed or already written in the toys. And this is the joysticks. This is called as joysticks, and with the help of the joysticks, generally what we do that generally the children they play with their mobile vehicles, okay, and sometimes this type of systems is also used for actual systems for controlling the wheelchairs. Okay, so those who cannot walk, so they are always sitting on a wheelchair, and they can control the movement of the wheelchair with the using of these joysticks devices. And the joysticks is also used for gaming purposes. Okay, and there are video games are there. So the children they play the video games. They control the movement of the cursors in the video games, using this handheld device, and which is known as a joysticks. So you have to hold these joysticks. You have to hold the joysticks properly, and then you can move the joysticks. Okay, in the left, in the forward and the backward direction, in the right direction, in the left directions. You can move it. You can also rotate it to some extent. You can also rotate it. So all this will give some sort of informations to your toys. Okay, for doing certain activities.
এই খাবে তো আজকে? খাবে তো? তুমি বলেছি কালকে খেয়ে নিও, কাল পরশু 5 দিন।
Whatever I'm finding, I'm just
না করবো,
you have to assemble all these informations of the knowledge to make the toys. For the toy making purposes, there are some we require some sort of small motors. Okay, smaller systems. And generally, what is available in the market, these motors are quite bigger in size. Okay. And if you want some sort of small motors, then this is one motors. These are called as a servo motor. Though it is very costly motors. Okay, so whatever the humanoid robot I have shown, so in that humanoid robot, this kind of motors are used for power purposes, for to act as an actuators. Okay, and this the size of these motors are very small, and these are feedback system. It has a feedback, so it has a position feedback. And it has a, from the position feedback you can calculate the velocity feedback that you can do it very easily. And not only that, it has also the current sensors also.
এখানে পার্টিসিপেন্টসের লিস্টটা দেখো এইটা।
So if you want to get some sort of torque,
স্ক্রিন প্রিন্ট করে একটা ডক ফাইল খুলে রাখো, ওখানে পর
that has been
1 ঘন্টা 2 ঘন্টা অন্তর মাঝে মাঝে স্ক্রিনশট নিয়ে এ করে ওইগুলো দিতে হবে।
there also you can
ভিডিও
measure
থেকে
it.
স্ক্রিনশট নেওয়া যায়
And
না।
this torque sensors means once you measure the torque, then from there you can definitely you can control the movement of the actuators or power of the actuators. For that purposes, aluminium means aluminium components, and for making body of the toys, then you have to use some sort of a belt. So this is a belt. Okay, so these are the belt. So all the motion transmission elements which are used in a mechanical systems, like say for example like gear, pulleys, okay, belt, and then cam drive, okay, and so
আরেকটা কাজ করবে,
all these mechanical motion transmission elements you can use it in the but most of the cases what happens is
আচ্ছা বলে দাও কালকে কি খাবে না।
is basically a very small components.
হ্যাঁ,
So
বলে
if
দাও
you
কালকে
use
কি
some
খাবে
sort
না।
of mechanical components, then the size of the mechanical component will be very small size, and sometimes there is a restrictions of using the toys. Okay, so
ওকে বলেছি এমনি
age
নর্মাল
of
খাবার
the
খাবে।
children is very important.
শুয়ারের বাচ্চা
Okay, so at the lower age group children, for them there should be as minimum as possible. One should use the mechanical small components.
হ্যাঁ কেন
কলেজের প্রোগ্রামে যদি নেন না দেয় তাহলে কি করবে?
Sometimes what happens now, you come to the manufacturing side, manufacturing of the toys, how we can manufacture the toys. Now, toys manufacturing is not a very easy job, okay, and sometimes what happens, before you come to the final shape and dimensions of the toys, you have to go through some secondary operations, okay, you have to go through some primary operations, and that primary operations requires, like say for example you make a toy, okay, and then you try with the different components whether all the components are working fine or not. You see the aesthetic beauty of the toys, and then you may go for the second version of the toys, some kind of improvements. You can do it. So in this way, before a toy is come into the market, you have to make a number of prototypes. And the prototypes by the conventional methods is very, very costly, and it's also time consuming. So that's why nowadays most of the typically they are using technology which is known as a 3D printing technology. So I'm just showing some components developed through the 3D printing technology. I hope in
আচ্ছা অসুবিধা
না, না,
নেই
অনেক
your
জিনিস
institute
অনেক জিনিস
also
আছে।
may have some sort of 3D printing machines through which the students may be developing some
পেছনে দরজাতেও আছে
components which are used for making
আর
the product.
ঢিকিতেও
And
আছে,
this is
ঢিকিতে
just as a
ঢিকিতে
handle.
কিছু করে চাবি
So
বার করার কোনো
maybe
পেছনে
for
ইয়ে
stopping
আছে।
of the be good looking. Also at the same time, it must be able to take up the load.
এটা
The
তো
load
এটা
means
লাগে।
whatever the torque will be
ওটা
applied
ফাইনালি
to
সব
this
লাস্টে
part,
একবার দিলে তো
it
সবগুলো
must be
লাগবে।
able to sustain that torque. That is essential.
চলো না
Okay.
আর কি কি আছে স্যার যা আছে বলতে লাগবে
So
হ্যাঁ,
what we
পেছনে
can
অনেক
do
আছে, শুধু
as an
আলগারটা এনো না।
engineer, we can make
আলগারটা শুধু
this kind of its components through some CAD modeling software tools, and then these CAD modeling software tools, whatever the model will be built, so that will be exposed to the 3D printing process, 3D printing machines, and the 3D printing machines within a very short time period, the 3D printed machine will print these components. This will print these components, okay, which you can use it to your toy. And this can be used for initial purposes unless and until your design is fixed, okay, your product is fixed, and when you decide that you will go for the manufacturing, then it will be always it is advisable to go for the conventional type of manufacturing, because in that case conventional manufacturing, if you employ the conventional manufacturing process, then the cost of manufacturing of the product may be lesser than the 3D printed one. Okay, so that's why we always prefer that we should go for a 3D printed one only during the prototype development. Once the prototype development is over and your design is conceived and it is freeze, okay, and your product is more or less final, okay, no trial and error, means testing is required. So, and then you go for the manufacturing, go for the commercializations of your product, commercial manufacturing of your toys. Then at that time you use the conventional methods of manufacturing of the toys, and but before that we should use this 3D printing concept, okay, and which is less costly. Also less costly during the design phase, it will be less costly, and also at the same time, that time